User's identity has always been a major point of discussion in 5G. Until now, the user's or the subscriber's identity that we call MC was sent to the home network as a plain text, which was the cause of a problem called the man-in-the-middle attack, in which an external third party can watch and intentionally change the value of MC, which may cause some problems in the network and which the attacker can further exploit for his own profit. This is how an MC catcher violates network security. In 5G, the concept of Suki was introduced. Subscription permanent identifier is sent in a protected way where we encrypt the Suki and then it is sent as Suki or the subscription concealed identifier. Suki to Suki conversion is performed with the help of asymmetric key encryption, also known as public key cryptography. The scheme that is used in this whole encryption and decryption process is ECIES, or Elliptic Curve Integrated Encryption Scheme. This cryptographic scheme is completely insecure against quantum computer attacks, and according to Post Quantum Telco Network, this needs to be replaced with a strong Post Quantum Cryptographic algorithm. Coran Labs presents its new product, QORE, a quantumized 5G core that uses Crystals-Kyber integrated with quantum random number generator for the encryption of Suki and decryption of Suki. This quantum proof algorithm encapsulates the home network public key and creates shared secret and ciphertext that is then used to create a shared key which will encrypt the Suki and generate the Suki. Similarly, the ciphertext is sent to UDM in the 5G core, which then will perform decapsulation to generate the matching shared secret as UV, which then further generates the same shared key that will be used for the decryption of Suki. QORE ensures the security of subscriber identities against all foreseeable threats, establishing a new standard in network security resilience. Our product QORE provides a total of 5 profiles. The profile E provides the most advanced level of security that can be achieved in the 5G core. This profile is end-to-end tested with a 5G network, which makes QORE the most secure 5G core in the market. For using Kyber keygen and the key encapsulation and decapsulation mechanism, we require lib or QS, which is then merged with the source code of UDM of 5G core, as well as the UV RAN simulator. The keys are generated through Kyber keygen. In Kyber keygen procedure, the seeds are provided through the quantum random number generator, making the home network public key and the home network private key truly random. This is the UV simulator and this is the home network public key that is generated through Kyber. You can see the length is sufficiently long and this is the protection scheme which is set as 5, which indicates the usage of profile E, in which we further use Kyber as well as QRNG. We will start the GNB using this file and have a look at the logs of UE and UDM where the encapsulation, decapsulation, encryption and decryption of Suki and Suki is done. So this is the 5G core con file and we are at the UDM section. You can see the profile E that is being used and the profile E public key is longer than the keys of all the other profiles. Similarly, the length of the private key is also sufficiently long. So these are the Kyber generated keys with QRNG providing the seed. These public and private keys will be used for the overall Suki to Suki conversion. We first start by executing the simulated GNB. After running the command, we can see it says the NG setup response is received. This means that the NG setup procedure is successful. Before we start the UE, let's have a look at the logs of UDM. These are the current logs of UDM that are generated. After this, we will start the UE. So here it says that the PDU session has been established and the IP has been sent to the UE. Now let's have a look at the logs of UE. It says that the initial registration has been sent and the protection scheme is set as 5. So it means that profile E is used where the encapsulation, decapsulation and encryption and decryption is being done through Kyber. So this is the ciphertext. We will also compare the ciphertext to the one we will receive in the logs of UDM to validate the whole procedure. These are the shared secret encryption keys. So now let's have a look at the logs of UDM. So here the protection scheme is 5. So the E profile is used and this is the ciphertext. So this ciphertext is similar to the one we received in UE. And you can see the private key here, it is larger as it is generated through Kyber. Similarly, in case of public keys, these are the encrypting keys, the decrypting MAC tag, and the decryption was successful. You can also see the MC and how the Suki is finally converted to Suki. So this was the initial Suki sent from UE to the UDM in encrypted form, and now the corresponding Suki has been generated. This was the complete flow through Kyber, where the encapsulation and decapsulation and overall authentication is also done using UE and UDM. This is the PCAP for initial NAS message used for registration. So now let's have a look inside PCAP. If you look at the PCAP file, we have a lot of parameters over here, but the main one we are focusing on is the protection scheme, which is 5. And again, this is sent for the profile E, which is using Kyber and QRNG. If you further look at the scheme output, the scheme output is same as we are getting in the logs, which is used for the validation of the overall procedure. QORE from Coran Labs redefines 5G network security, setting a new standard for protection and resilience.